right? So we'll say that this data is ungrouped, which means that this data, for example, represents number of children in families, in different families, okay? Right. So number of families and then the number of children in families. So yeah, we have this is representing a family with only a child. This is a family with three children, a family with no child, and so on. So if you want to organize this data, as you can see it now, it's just a list of numbers, and you may wonder how, if I tell you that which number of children is the most, all right, in a particular family. By just looking at this, you may not be able to figure it out. But if you are able to fill in this table with this data, you will be able to see more easily and faster, okay, which family has the most number of children. Okay, all right. So we're gonna start by filling in the. We'll start by filling in the tallies. We'll use the tally. This column is not so necessary, but it is useful to fill in this frequency. So we'll say that this is the number of children: family with zero child, family with a child, family with two children, family with three children, family with four, and family with five children. There's a family here with six children, so I'm going to add it. It didn't show. In filling in to know the frequencies, which is, that is how many families have no child, how many families have just a child. That's the frequency column here. Let's start. I'll take them one by one. So if I see what there's one here, so I cross it out. Then I come and tally against one. I cross this out, tally against one. Then this is three. So against three. Let me rule line so that it will be very much easier for some people. So I filled in one, then three. So two, zero here, two here, zero here, one here, two against two again, two. Now one. See, that's why it's helpful when you're using the tallies, because at this point I don't get confused. I just continue from the next number because I've tallied up until where I've cancelled out. So once I cancel, I make sure I tally. So I just continue. So the next one is three against three, five against five, two against two. Now I'm tempted to do here, but usually when you're doing tally, and when you were able to mark 1, 2, 3, 4, the fifth one, you don't stroke like this. Okay. The fifth one, what you do is that you just cross out this, which signifies five, a count of five. So 1, 2, 3, 4, and then the stroke five. Now I have again here 4, so I write here 4. 0, 0, 0, 0. 2. So I start a new one, 2, 4, 4, 1. Now 1, I see 1, 2, 3, 4. So I'm going to cross out 5 here. Another one here. So I'm starting a new one. So 2, 2, 2, 2, 0. Now 1, 2, 3, 4. So 5. All right. So 3, 3, 0, 0, 0, 0, 2, 2, 1. All right. So I'm done with my tallying. As you can see, I've crossed out all the numbers. Okay, so it makes it quite easy to deal with. You realize that this is very important because, for example, look at the number of families that have 0 children. I know this is 5 and this is 5. So 5 plus 5 is what? 10. If I had done all just stroke, I'm now coming to count 1, 2, 3, 4, 5. So putting them in blocks of 5 really makes the subsequently counting to find the frequencies much easier. So I know this is 5, that's 10 plus 1, 2, which is 12. Okay. Here is 5 and then 1, 6. Here we have 3. This is 1 and then this is 1. So what does this frequency mean? I want to know my total frequency. 10 plus 12 is 22. Plus 14 is 36. Plus 6, 42. 45, 47. You realize that the number of families that have no child is 10. Number of families that have just one child is 12. So of all these, looking at the frequencies, okay, which number of children in a family is the most? The number of families that have only 2 children stand out. They are the most, okay. Okay, so This is a very simple way if you have a very simple data, how to fill in a table. You realize that because I filled this data in this table, when I ask the question, which number of children in the family is the most, is 2, because you can see here 14 is the greatest. But if it was in this raw form like this, without this table filled out, could you have figured out that 2 is the most, is the mode? Yeah. So it means that when you organize your data, it really simplifies things for you and it brings out more information in your data that you cannot see when you have it in the raw form like this. But you see, when you have it in the table like this, you can see some very important information is coming out. Okay, right. What we did initially, we looked at ungrouped data, and then we moved on to form the ungrouped frequency table. Now, this is another kind of table. Remember, I mentioned that we have the ungrouped table and then the group table. Now, this is how a group table typically looks like. It can have more or less of these components, these various components. It can have more or less of them. Okay. So if you take this interval, for example, we call this portion the class intervals. Now, the class interval shows you the kind of data or the data that you have. But unfortunately for you, you won't have this data as simple singular data points like you have here. You have 1, 3, 2, 0, and all that. And you only have groups. So all the numbers that fall from 1, 110 up to 129 are all merged and put in this group. All the numbers that fall from 130 to 149 are all put in this group. All the numbers from 170 to 189 are all put in this group, and so on. You can see that we don't have the data points, but we have the data groupings. So if you have a table like this, it means you don't have access to the exact data points, but you can still make do with this and work something out. Now, as you progress, you will come to know all these other columns and how they come about, okay, and how you can work around them. All right. So okay. Please note that some of the values have been let out, but that's not here. This number here is not here. This is not here. This is not here. This is not here. There's supposed to be numbers there. You can actually fill in this table if you understand what each column means. But because we haven't spoken about that, we will just skip and move on. As we move on, you will begin to see these various columns will evolve and you begin to see how useful they are. Now, we want to first look at our first graph, and that's going to be a simple bar chart. So we'll be using this data to draw our simple bar charts. Okay, this is how it's going to look like, but we'll draw it together here. A simple bar chart. If you want to talk about bar charts, we are looking at as if you, for example, if you have seen a graph sheet before, or you've done anything about regarding graphs before, you know we have the X and the Y axis on a graph. So let me imagine a graph plot here. So I label this as my X axis, and then I'll label here as my Y. Okay, right. Now, in this data, month is going to be my X, and the number of X will be my Y. All right. So I have 5 months, 1, 2, 3, 4, 5. So I want to write them down. January, February, March, April, and then May. All right. Now let me look at my data here. I have to fill in this. I have the smallest number here is 10, and the biggest is 50. So in labeling my y-axis, I need to make sure that at least I have a 10 and at most I have a 50. So I'll just, the intervals must be even. Okay, so I'll start here with my 10, 0, 20, 30, 40, 50. Let me just extend a bit to 60. All right. So for the month of January, how many X are there?
10.
10. So I'm going to start. Remember, I'm doing bar charts. Okay, so I'm supposed to draw a bar above January. I'm going to draw a bar. I'm going to extend the first left line up to 10, move right, and then bring it down here. Okay. So this is for the month of January. There were 10X. So here I have to label here as month.
and label here as number of eggs, my y-axis. February has 35 eggs. So I'll start from the left all the way up, to 35, which is somewhere here. Come right, and then all the way down. Okay, this is February. Now for March, there were 40 eggs. So we start again all the way up to 40, right, and then down. I'm sketching, so of course I don't have straight lines, but once you are using a graph or you're drawing in Excel, you have very straight lines. And then we have the month of April, there were 50 eggs. So we go all the way up here, 50 eggs, and then down here. Then finally, the month of May, there were 30 eggs. So we will come up to the point of 30, up to 30, right, and then down. So this is my bar chart. I have to label it as my bar chart. Okay, yeah. And this is what I have. So it's okay. I can also use some form of patterns to mark them if I want. I can leave them plain also if that's how I want it. Whichever, if you prefer, you could use dots. You could also leave it like that. Once your border lines are very visible, it's okay. But if they're not visible, do some patterns in it like this to demonstrate your bar charts. Remember, these things, what I've just done, can easily be done with Excel, easily. Okay. So what we just did is this is what I was able to produce in Excel when I tried it, and I posted it in the notes. Okay, so this is a much neater, very, very neat and very descriptive of what we just did. Now, we also want to look at another kind of chart, and we call this chart the multiple chart. Okay, the multiple chart. Now, with this particular chart, you have for every particular month, you have two different bars. Okay, so let's attempt to produce that chart. All right. So I'm going to start again with my y-axis and then my x-axis. Okay. I have 5 months as usual, J, F, M, which is March. I do MR for March, April, and then May, MY. Okay. All right. Now, brown and white. So I'm going to use diagonal lines for brown eggs, and then I'll use dots for white eggs. So in January, okay, let me do my scaling first. So I have my Y labeling 10, 20, 30, 40, 50, and then 60. So in January, there were 10 brown eggs, and then 5 white eggs. Okay. No, this is too small. Okay. So I have 10 brown eggs, and then 5 white eggs. Okay. So brown horizontal diagonal lines, then white dots. In February, I have 35 brown eggs and then 37 white eggs. So a little bit above that and then all the way down. So brown, I'm going to use my diagonal lines to signify my brown, and then my dot, my white eggs. March, 40 brown eggs, and then 45. So I have 40 brown eggs, and then 45 white eggs. April, let me stop here. I think you've gotten what I'm doing. So this is how you go about doing a multiple bar chart, okay? If I had a third column, let's say brown eggs, white eggs, and yellow eggs, if there's anything, for each month, I'll have 3 bars. So it flows like that, okay? Right. So this is how you go about drawing your multiple bar chart. If you look at this as compared to the simple bar chart, they have single bars, but with the multiple bar charts, you have 2 or more based on the number of data or the number of this based on the number of kinds that you are provided to draw or you are working with in your data. All right. So we will just move to the next page and then look at the final output of our multiple bar charts. So this is the final output that we got from the software for a multiple bar chart. So you can see Here, because I was using hand drawing, typically you'll be drawing with a pencil or whatever, so you won't have colors to be able to distinguish. But if you are drawing with a software like Excel, you can easily choose colors to distinguish. As you can see, we use brown, the blue color for brown eggs, and the green color for white eggs. In my case, I use horizontal lines, no, diagonal lines for brown eggs, and then dotted dots for white eggs. So whatever you choose. You can choose vertical and horizontal or any other pattern. Okay. Now the next chart we want to look at is the component bar chart. The component bar chart. So I'll start illustrating it. I'll stop halfway and then we'll go look at the final output in the next slide. So for component bar charts, once again, you will need your X and then your Y axis. I have my months, January, February, March. Please, pardon me to end here. You should do April and May, but I'm pausing here. Then I'm going to label from 10. It's the same kind of data as you can see. So it's as if our y-axis is being labeled the same. It's not always 10, 20, 30, 40. Oh. You have to look at the kind of data you have and use it, okay? So if the data is such that the highest number is, let's say, 15, then you probably may use 2, 4, 6, 8, 10, 12 on your y-axis instead of this. Because you must choose a scaling that allows your graph to be a bit big enough. You don't draw a small graph in a corner somewhere here and leave all the space around, okay? 10, 20, 30, 40, 50, and then 60. But the truth is that you are not likely to draw graphs in examination. You'll be interpreting graphs, okay? So I'm most likely to provide for you graphs for you to interpret and then define and make analysis out of the graph you have. But the fact is, you cannot interpret a graph if you don't even know how the graph came about. If you don't know how the graph was put together, you can't answer questions on the graph. That's why I'm doing this with you, so that you will know how actually the graph is put together, what comes together for us to put the graph together, so that when you have questions to answer on a particular chart, it will make more meaning to you and you'll be able to answer questions to that effect. Right, so for month of January, now once again, I'm going to choose the diagonal lines for brown eggs and then the dotted ones, okay, for white eggs. Okay, so let's start with January. January has 10 brown eggs and 5 white eggs. So for the component, what happens is that I'm going to first of all do for my brown eggs, which is 10 of them. Then I identify them as brown eggs. Then white x is 5. So I'll start from here and then I draw back to 2.5. Okay. All right. So from 10 to 15 is 5 counts. Okay. So this is representing oh, my white x. I hope you can see. So for components, you put the other on top of it. You don't do them side by side. You draw one on top of the other. Now in February, I have 35 and 37. So I'll start off, first of all, start with, it means that even this, my y-axis has to go up a bit. Because if I start here with 35 as my brown eggs, now I'm going to count 37 in addition. So what I'll do, I'll just pick my calculator. 35 plus 37 is what? 72. So I know I need to go up on this thing. 70, 80. Okay. So I'm going to now move all the way to I reach 72. And so I expect that from here to here is 37. From here to here is 37. Okay. Right. But it's an easy way of doing it is just take 35, add 37, because you're going to put 37 on top of 35. It will give you the point of stopping where you stop. So you just do it that way. Now for the month of March, I have 40 for brown eggs. and then 45. So I realized I even have to increase my y-axis length. It's still short. So with the components, you have to be very careful. Yeah, you may have to be extending your y-axis as you go on, but if you're able to see it ahead of time, that's great. So 40, this is 45. So 40 by 45 is 80. This is 90. And then 100. 40 plus 45 is 85. So I expect to go all the way to 85. And then this should give me my white X for match. Okay. So 85 minus 40 here is this space here. From here to here is our white X. So you do the same for April and then May. Okay. So you realize that in this case, I have been able to put together my components bar chart. I didn't finish, as I said, you just continue the process for the month of April and May. So let's see. This is what we expect to get for a component bar chart. Okay. Right. So you realize that in this case, we use color blue for brown X, white for white X. So here, brown X for January was 10. So we had 10. And then for white X for January was 5. So we added a 5 on top of that. From here to here is 15. Which is the total. Okay, so you can see a big difference. This is component bar chart. Labeling is there. The nature of the graph you can see. Then if you come to the multiple, you can see it's also very different. So the bars are side by side, and then we have the name of the chart, multiple bar charts. This is the data we want to use to draw the next chart, which is that we call the percentage bar chart. There isn't much of it. How would I even say it? Okay. It looks like a components bar chart, but it's different. Okay. Now, in this case, you'll be working with percentages. In the case of components, we use the raw numbers and then we place one bar on top of the other. In the case of percentage bar charts, we will also be placing one bar on top of the other, but we will not be using the raw data. We'll be using the percentages. So what happens is that once you are given a data, you must convert them to percentages, okay? So for example, there are 10 brown eggs for the month of January. How did we get 67%? So here, let's say I have here 10. This is my 10 out of the total, which is 15 times 100. Okay. And that's if you use a calculator, you find that 10 out of 15 times 100 is 67%, okay? Here we'll have. So if it's the case, I can also do for white eggs. In the case of January, that's going to give me 5 of them out to the total of 15 times 100, because I want percentage, so 100%. And if you calculate this, you're going to get 33%. February, total is 72. So for brown eggs in February, it's 35 out of 72 times 100%. And then white eggs for February, we have 37 of them. 37 out of 72 times 100%, and that gives 51%. All right, so I can move on. So let's say we've done all of this and we have gotten our percentages. Okay, so in drawing our percentage bar chart, we are going to ignore the actual numbers and we'll be working with percentages. So our focus is going to be on the percentages. Okay. Okay. So I'm going to try to draw my chart, my percentage chart. Now, for percentage chart, the y-axis is very simple and straight to the point. You always have to label to 100%, okay? Because your graphs will all reach 100%. Please pardon me. Because of space, I don't really write, but ideally, let me actually write so that you know that this is what the right thing to do. Okay, so I'm going to leave some, manage the space I have here. Okay. Now, this is y, which is my I'm going to start from 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90. And then 100. Okay. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100. So I'm going to label this place as percentage. Okay. Now this is going to be my months. On my x-axis, I have my January, February, March, April, and then May. Because of space, I mean, things are shortened. Remember I said I'm working with my percentages. I'm not going to work with the actual numbers. So my focus is going to be on the percentages. So for January, but one thing you should know is that if you add 67% to 33%, you're getting what? What would you get?
100.
100%, right? So if you sum the percentages for each row, it will all come to 100%. Okay. So for the first month of January, brown X is giving me 67%. That's somewhere here. So I'm going to trace it down. And then I have this. Okay. So once again, let me use my diagonal for brown X and then my dot for white X. So January 67 for brown X and then 33% for white X. 67 plus 33 is going to give us 100. So it goes all the way to 100. So this is my brown X and here is my white X. All right. February. Brown X are 49%. So let me find 49. 49 is going to be very close to 50. So somewhere here. Then I come all the way down here, all the way down, which is my brown X. Okay. So I've been able to for the month of February, brown X is 49%. Now white X for that same month is 51%. 51 plus 49 is 100. So I'm going to extend it all the way to 100. Okay. Then I create for what I need for the white X with my dotted line, with my dots. Okay. All right. So let's do the last one for March. On your own, you can do for April and May. For March, brown eggs, we have 47%. Okay, so somewhere here. Okay, so I'm going to extend it all the way here like this. And then do my dash, 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 dash. Then for white eggs, it's 53. 53.47 should give us 100%. Okay, with my dots. So you will notice that each of the charts or the bars will always extend to 100. The extension will be within each bar, how much of the percentage of the 100% is for brown eggs and how much of it is for white eggs. Okay, which is this? This is what I just did. What we want to look at next is a simple line graph. Okay, a simple line graph. So with that, you just have some month which you represent our x-axis, and then we have the number of, so in this case, we have some months, we have the number of x, and we want to use it to draw a simple line graph. So what does it look like? So what we're going to do is that we will, once again, draw our x and then our y-axis. Here I have, okay, another question. So I have here, this is my y, this is my x. 12 months. 12 months. So let me extend my x a bit because I need a lot of space for it. Hey, Richmond, please, what are you doing to me now? Kindly try not to write on the screen, okay? Okay. All right, so 12 months, I'll start from January, February, March, April, May, June, July, August, September, October, November, December. Okay, let's look at the Y labeling. Now, the highest number here is 20. So if that's a case, I don't have enough space, so I'm going to label from 4. I'll use the scaling of 4, 4 to 1, so 4, 4, 8, 12, 4, no, 16, and then 20. Okay. So for January, there were 4 eggs. So I'm going to use a simple dot, or you can use a star. You can do this. I'm using a simple dot. February 8, so here. March 6, so middle of 4 and 8. April 18, so here. May is 20. June 19. July 15. Mine is not accurate, so please take notes. Okay. August, we have 12. September is 14. October 16. November 20. So 20. And then December 10. Okay. All right. So I've plotted the dots for each of the number for each of the months. Okay, so what I do is, it's because it's a simple line graph, what you do is just connect the dots. But connect them sequentially. Okay, so we have from January to February to March to April to May to June, and then to July, August, September, October, November, and then December. So this is a simple line graph. Okay, yeah. Okay, the one more graph you want to look at is the histogram. If you want to draw histogram, what do you need? As you have seen previously, in the case of, for example, percentage bar charts, once you want to draw a percentage bar chart, what you needed was your percentages and then the date, the number of months or whatever x axis values you are looking at. Okay, so in the case of histogram, we are not going to use simple data. We're going to be using grouped data. Data that we don't have the actual data points, but the points are grouped, they're categorized into groupings. So here we have data points from 1 to 5, data points from 6 to 10, data points from 11 to 15, and then so on and so forth. The final data group is 41 to 45. Okay. So to draw a histogram, we need frequencies, which we have seen already. If you have a list of data points and you have the groupings like this, any number that falls from 1 to 5, you've put it here. So it means there were 3 such numbers that fall between 1, or that were either 1, 2, 3, 4, or 5. So maybe it was 1, 1, 1, or 2, 3, and 4, whichever. Okay. We don't know them. But what we know is that there were 3 numbers in the data set that were either 1, 5, or between 1 and 5. This shows that there were 7 numbers in the data set that were either 6, 10, or between 6 and 10. Okay, so that's the range for each of them. This means that there were 20 numbers that were either 21, 25, or between 21 and 25. Okay, so to draw a histogram, you need, first of all, the frequencies, and that will be on your y-axis. Okay, and then you also need your class boundaries. So yeah, in working with class boundaries, what we are going to do is that you need to know your class intervals. So let's say we are given the class intervals. How do we find the class boundaries? Okay, so I'm going to help you with that. Okay. So how do you find class boundaries? So to find class boundaries, choose any two class intervals that follow each other. So you could choose, I'm going to choose any two class intervals that follow each other. So I'm choosing these two because they follow each other. Okay, that are, I don't know the right way to use. It could be these two. Any two that follow each other. Okay. So I'm going to work with these two. Now, I'll consider the okay, right. Let me label these things very well. Okay. Now for any class interval, so I'm going to go back a bit and then do some labeling here. For any interval, let me take this particular interval. It could be any of them. The 6 here, we call it the lower class limit. And then the 10 here, 10 is the upper class limit. Okay. So I'm saying that 6 is the lower class limit, and then 10 is the upper class limit. Okay, take note. Now, if I take, I'm going to talk about this, okay, but let me label the points first. If I take the class boundaries, any of them, any class boundary, then I'm going to say that the number on the left here is 10.5. We call it the lower class boundary. And then this number, what I've used brown for, 15.5. It is the upper class boundary. Now, what I want to do is I want to show you how to calculate for the class boundaries. How do you find class boundaries? Okay. So to find class boundaries, I'll choose any two class intervals that follow each other like this. Now, I'll consider the upper class limits of the first one. This is my first one. This is the second one. Now, I'll consider the upper class limits of the first one. So the upper class limit of the first one is what? 20. Okay. So 20 minus. Then I'll consider the lower class limit. The lower class limit of the second one. So 20 and 21. So I'm considering the upper class limit of the first one and then the lower class limit of the second one. Okay. So what I'm going to do is I'm going to take out the upper class limit of the first minus, take it out of the lower class limit of the second. So I'm going to have here 21 minus 20. Okay. 21 minus 20. And that's giving me 1. Then I divide it by 2, which is what? 0.5. Okay. So once I have my 0.5 here, what I'm going to do is that I'll come to the class interval. Now I will take out this 0.5 which I have. Okay, I'll pick it. Now for all the lower limits, I'll subtract 0.5. And for all the upper limits, I'll add 0.5. So if you consider the first one, for example, 1 to 5, if I subtract 0.5 from 1, I get 0.5. Then if I add 0.5 to 5, I'm getting 5.5. The second one, 6 minus 0.5 is 5.5. 10 plus 0.5 is 10.5. Third one, 11 minus 0.5 is 10.5. 15 plus 0.5 is 15.5. So I did the same for all the others. Look at the final one. 41 minus 0.5 is 40.5. Then 45 plus 0.5 is 45.5. So if I apply this, I can fill up my class boundaries and then I have my class boundaries. Okay. All right, so now that we know our class boundaries, you want to move on to draw a histogram. I mentioned to you that to draw the histogram, you need frequencies and then you need class boundaries. Okay, let me just write this thing, indicate it. So here, subtract 0.5, you add 0.5. And it runs down for all of them, all the others. Okay. Subtract 0.5, add 0.5. Okay. Now let's draw our histogram. We've been able to create our class boundaries, and we've been able to create we already have our frequencies. So yeah. All right. So to draw the class, the histogram, I sure need my line for my y-axis, and then I need my x-axis. Okay. For the histogram, you need the class boundaries. So what we are going to do is start the labeling. Okay, so I'm going to start, right. The first boundary is 0.5 to 5.5. Okay. The frequency is 3. So from here, here, and then here. And I have my first batch, my first bar for this one. The next, I'm now with this one. The next boundary is 5.5 to 10.5. I already have 5.5 here. So 5.5 to 10.5. The frequency is 7. So I go all the way up, down. Okay. The next one is 10.5 to 15.5. So 10.5 to 15.5 is 17. So I'm going to look for 17. Come. And then all the way down. The next chart is 15.5 to 20.5. So 15.5 to 20.5. Okay. And then the frequency is 22. Okay, so 22, I come here and then down. All right. They join, please, because I'm sketching. The next one is 20.5 to 25.5. So 20.5 to 25.5. So, and that the frequency is 20. So I come here and then down. The next one is 25.5 to 30.5. So to 30.5. Frequency is 18. So I look for 18 and then I come all the way down. Great. So we'll continue for the others. I don't have space. I can't do it. But one thing to notice here is that for the histogram, because of the class boundaries, you realize that the bars are joined. They don't have any gaps between them, the way you saw it in the bar charts, the simple bar charts, or even the other ones, the multiple, the component, the percentage, and all that. For histogram, there are no spaces between the bars. It's because of the class boundaries. You realize that the end of one boundary is the beginning of the other boundary. Okay, so here the upper boundary for the first one is 5.5. It's also the lower boundary for the next class boundary. Okay, that's how come it is the way it is as you see it. The next one is the frequency polygon. All right, so in drawing your frequency polygon, once again, you may be given a grouped table, as you can see. But for frequency polygon, you will not be using class boundaries. You'll be using class midpoints. So there's a different chart and then a different kind of information that you need to draw your chart. Okay. Class midpoints. Class, how do you find this column? This is a new something. All this is when if you remember the very first chart I showed, the very first table I showed you, that has so many components. I told you as we are moving on, all those components will be unveiled. So I'm sure as you go through your notes and then you see them, you'll be able to now you appreciate and understand what they are and at what point in time you need for what particular chart you are drawing or what particular organization of data you are doing. Okay. Right. So how do you find the class midpoint? You take a particular interval, let's say this one. Take the lower limit, add it to the upper limit, and then you have 6. Divided by 2, you get 3. And that's what we have here. Let's take 11 to 15, for example. We have 11 plus 15, that is 26, divided by 2, and that's 13. And we have it here. Let's take 26 to 30. 26 plus 30 is equal to 56 divided by 2, and that's 28. And we have it here. Okay, so to find class midpoint, just pick a particular interval, sum their limits, divide by 2, and that gives you the class midpoint. Take note, this is an approximation. Let's move on. So we want to draw the frequency polygon. So I'm going straight to what we need. You need your y and then your x. Your x is going to be your class midpoint. And then your y, sorry, class midpoint. I've shortened hand, sorry, please. I'm running out of time. Then the y is the frequency. Okay. So I'll take each midpoint and then I will start. The midpoints, we have 3, 8, 13, 18, 23, 28, 33, 38. Please, I've run out of space, but you have to finish it up. Now you take a particular midpoint, look at midpoint, the first one, which is 3. The frequency is, okay, let me fill up my y first of all before I start drawing my points. The highest frequency here is 22. So I'm going to use count of 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Okay. So 3 has a frequency of 3. So that's it. You just use a dot or a star. Okay. 8 has a frequency of 7. So that's here. 13 has a frequency of 17. So I'm going to look for 17. And I think that should be somewhere here. If it's in a graph sheet, you really be able to follow it properly and do a proper graphing. I'm just catching. 18 has frequency of 22. So we have here 22. 23 has frequency of 20. So 23, frequency is 20. 28 has frequency of 18. 33 has frequency of 15. 38 has frequency of 8. Okay. All right. So now that I've been able to plot my points, I didn't finish. We'll take note. I said we should continue. I don't have space. So what do? Why don't you be able to point, indicate your point? The next you do as similar to the line graph we did. It's just joining the points, but consequentially, okay? So we start 3 to the 0.8 to the 0.13 to the next one, next, 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 and then on you move on. So this is how you draw your frequency polygon. Remember, you need a class midpoint and you need your frequencies. So this is what I just drew. Okay, this is the demonstration of it, the frequency polygon. You have the class midpoint, the frequencies. Okay. So the final chart we'll be looking at is called the cumulative frequency graph. Another name for it is the ogive. Ogive. So this is the data we want to use to draw our ogive. Now here is what I was referring to, the upper class boundary. Okay, I mentioned that I almost mistakenly used upper class boundary to draw histogram, but that was wrong. The upper class boundary is used to draw the ogive. Okay, so for the ogive, what you need, 2 main data that you need to draw an ogive is the upper class boundary and then the cumulative frequency. These are what you need, the upper class boundary and the cumulative frequency. All right, you see all the other sections like class interval, class boundaries, frequency, because you need them to be able to arrive at what you actually need. You need to know your class intervals to be able to find your class boundaries. And you must find your class boundaries to know your upper class boundaries. Now you need to know your frequencies for you to know your cumulative frequencies. Okay. But if you have the class interval alone and the frequency, you can find all the others. Because we have learned how to find the class boundaries using the class intervals. So you can refer to that. And then you can, once you have your frequencies, you can find your cumulative frequencies. How do you find cumulative frequencies? You simply add on the frequency up to the point where you are. Okay. So in this case, the first one, I have 1. So the cumulative frequency is 1. I'll use CF to represent that cumulative frequency. Now the second one, this is the point where I am. So I add all this and all the others ahead of it. So 1 plus 3, and that gives me 4. Now in my third column, 17, I go back to my frequencies. 17 plus 3 plus 1, and that gives me 21. When I come to the next column, I come to the next frequency, 22, plus all the others before it. So 22 plus 17 plus 3 plus 1. For the fourth row, how do you find the CF? You take its frequency, and then you add it to all the numbers that come before it. So 22 plus 17 plus 3 plus 1, and that's 43. Now for the fifth one, you take its frequency, you add it to all the numbers that come before it. So 20 plus 22 plus 17 plus 3 plus 1, and that gives 63. So you do this for all the others, and you'll be able to find for the last one, you take 3 as your frequency. Then you add it to all the numbers that come before it. So 3 plus 6 plus 13 plus 15 plus 20 plus 22 plus 17 plus 3 plus 1, and that is giving us 100. Okay, so now that we have our cumulative frequencies and then we have our upper class boundaries, what we'll do is we'll plot the upper class boundaries against the CFs. So this is the cumulative frequency curve, or the ogive. Now you realize that in this case, we have here our upper class boundaries. Okay, then the cumulative frequencies. If you look at the table, you realize that the frequencies, the maximum number in the CFs was 100. So we labeled our y-axis well to be able to capture all that. We use the gap of 20, so 20, 40, 60, 80, 100, 120. So the first upper boundary was 5.5, okay? First upper boundary was 5.5. Here's the upper boundary column, 5.5, 10.5, 15.5. So 5.5, 10.5, 15.5. You can list them all on the x-axis like that. For 5.5, its cumulative frequency was 1. So we label this as 1. Now for 10.5, its cumulative frequency. So we are using just this to remember, I mentioned it early on, that we are using upper class boundary and cumulative frequency. 10.5, its CF is 4. So if you come back to the table, you have 10.5 and then retrace up to 4, okay? Now 15.5, its CF is 21. So you come back to the table, 15.5, you look for 21 against the CF, then you dot it. The next one is 20.5. Its CF is 43. So you come back to the next one, 20.5, look for 43, and then you dot it. Now you do it for all the remaining upper class boundary, trace to their frequencies. When you are done, you just connect the dots with straight lines, okay, like that. All right, so that's about it. The final thing here is the stem and leaf plots. Now, this is another way of presenting your data. This one is not those graphs and bars and all that, but but in the case of what we saw initially with the frequency table that we saw at the beginning, okay? The stem and leaf plots acts as another way of presenting your data, and it also helps you to know, gives you more information about your data, okay? But on this particular stem and leaf plot, in labeling it, this is my stem, and then this is my leaf. Okay, this is my stem and this is my leaf. Okay, now in this course we'll be dealing with only 2-digit numbers like 25, 15, 17, 33, 72. We won't deal with 3-digit numbers like 152. No, we will deal with only 2-digit numbers. So given this is a proper stem and leaf plot, okay? This is a stem and leaf plot, how a stem and leaf plot actually looks like. Now from this stem and leaf plot, I can figure out the data points that were used to do this stem and leaf plot. How will I do that? How do I find the numbers that were used to plot this? Now, the numbers in the stems are the tens, and the numbers in the leaves are the units, okay? So my first number is, if this is my 10, that means I have 1 here. Then the unit is 1, so I have 11, 1, 1. My next number is going to be, again, this one, which is my 10, and then the next one, which is my unit, so another 1, 1. Okay. My next number is 1 and then 3, so 13. Next, 1 and then 3, 13. Now my next number is 2 and then 6, 26. The next number is 3 and then 0, so 30. Because 3 is the stem, which is the tens, and then 0 is the leaf, which is the units, so 30. 3 and then 0, another 0, 30. 3 and then 2, 32. 3 and then 3, 33. 3 and then 4, 34. Okay. The next groups are 4 and then 5. So 4, 45, this 4 and 5. The next one is also 4 and 5, 45. 4 and 5, 45. 4 and 6, 46. 4 and 8, 48. 4 and another 8, 48. 4 and 9, 49. 4 and another 9, 49. 4 and 9, 49. Okay. Okay, I'm on the fifth one. So we have 51, 52, 53, and then 54. 7 has nothing here. It means there was no number which is 70 something, but there's nothing here. Then the final one is 88. So this is the data set that was used to create this stem and leaf plots. So what I want you to think about is, how can I create the stem and leaf plot if I am given this? If I'm given the data points, how will I create a stem and leaf plot? Given how I have shown you how I deduce the data points from the stem and leaf plots, I want you to think about this. So we should have added 65, 66, 67, 68, and then 68. Thank you for prompting me. I skipped it. I didn't see. Okay, fine. So until we meet again.